My name is John Crowson. I'm a senior software engineer at Capital One. I am on the Twitter webs. I'm at John_Crowson. Feel free to follow me. I'm going to post my slides later. And usually I'm tweeting about my favorite thing, which are NGRX and Redux. And today I get to talk about my favorite thing. We're going to look at understanding Redux by implementing it. Now you might say, John, why do I need to implement Redux in order to understand it? I have 10,300,000 tutorials on Google that are helping me learn Redux. And besides, the 800-pound gorilla in my code base that I feed all of my state to hasn't misbehaved in a really long time. At least this is how I envision NGRX when I'm integrated in my code base, kind of like a Donkey Kong. And it's true, there are a lot of great resources associated with learning Redux. You got the example apps, you have official documentation for the various Redux-based frameworks, you have boilerplates and tutorials and YouTube videos, podcasts, conference talks. But what I realized was I was spending more time learning Redux by trying to comb through all of these various resources than just sitting down with the code itself and figuring out how to work behind the scenes. I was just really dependent on these documentation. And what I found out was that this big, scary frameworks are actually really simple. Simple enough to implement in a 25-minute conference talk. So, what are my goals for today? The first thing is I want you to be independent of the documentation. I feel I've gained this at this point by understanding Redux and how it works. I understand all of my code, not just my consumer code, but the library itself, and I feel like it's all mine. I don't have to be so dependent on looking everything up and finding resources. And I want you to be fearless. I want you to move from framework to framework because you understand common components of each. If you have to go in and figure out why something's not working as you expect, I want you to see key pillars of the code so you're not intimidated going into by one of these frameworks. And then finally, to be the best Redux developer, you really have to understand deeply how that Redux works, how that code works. Just like to be the best Mario, you have to understand how that Donkey Kong algorithm works. So I want you all to be a better Mario. All right, let's look at the agenda. So first thing we're going to look at is implementing the Redux store. Now, for basic applications, this should be all you need. But as our applications get larger, we see and use some extra tools that a lot of these open source frameworks provide us that allow us to build production applications. The first one we're going to look at is MemoI selectors. MemoI selectors are going to allow us to store just the minimum state in our store and then derive data from it that is specific to our component, so our state isn't bogged down by all this component-specific data. We're going to memoize it, which is going to have performance gains. And then secondly, we're going to look at combined reducers. We like to write small, focused reducers. But how do we combine them all together and feed them to a framework, which most of them just expect a single reducer? So we'll look at that as well. Now, there's a couple ways I could implement a couple of these. I'm shooting for readability here. If you can't understand every line of code, at minimum, what I'm hoping is that you see just how little code it is. I'm going to lean on RxJS, very popular in the Angular community right now. And then I'm also going to lean on TypeScript, have some type safety in my framework. All right, let's put on our Redux caps. And for those of you that might not be Redux pros, let's review some of this data flow. If I have a client consumer application down here at the bottom, it has a dark mode and a light mode. By tapping on that sun, it's going to change the state between dark mode and light mode. Now, with Redux, we don't directly manipulate the state. Instead, if I was to tap as a user on that sun, we dispatch to a library an action, a Redux library. This is the toggle mode action. Now, the dispatch is going to be the only instance method we're going to provide to our consumers as a library. It's going to take in an action, and it's not going to return anything. It's going to do some things behind the scenes. First, it is going to call our reducer. A reducer takes in an application state and an action and returns a new application state. Now, this reducer is provided to us by our consumer. They say, this is how I want my state to be reduced. So we're just going to call that for them. And then the result of that application state is just going to be stored and overwritten by our current state. And behind the scenes, our state is just going to be a plain old JavaScript object. Now, we don't want to expose this state directly to our consumers because we don't want them mutating and mucking it all up. Instead, we're just going to expose them a nice observable. And that observable is just going to emit the latest state to our consumer. So these four kind of components here are going to be encapsulated in what we're going to refer to as our Redux store. All right, before we look at code, just a couple definitions. We have the action. So action's an interface, and all actions have a type, which is a string. We're going to use that to differentiate different actions from each other. And then a reducer function, which takes in a state, takes in an action, and returns a new state. I'm going to use the generic S to represent a generic state object, a generic state shape. So you'll see that moving forward. All right. We are going to implement our store in 11 lines of code. You guys ready? All right, a couple nods. There's one thumbs up. We're doing well. All right, I'm going to create a class. It's going to be our store class. It's going to be based on this generic state shape. The only method we're going to provide to our consumers is the dispatch method. The dispatch method takes in an action, and it's not going to return anything. Now, when you set up NGRX, or you set up my store in my use case, the only thing you provide it is a single reducer function. So in our constructor, we're going to take in one reducer function. When the user dispatches an action, we are going to call that reducer function that they've provided to us. We're going to pass in the previous state and an action, and we're going to overwrite that state. All state is plain old JavaScript object. Again, we don't want to expose the state directly. We don't want them mutating it, so we want to expose a stream. So internally, we are going to use an RxJS subject. An RxJS subject allows us to emit values to a stream and listen for new values. So we're going to use a behavior subject specifically because behavior subjects cache the last value that's emitted. So in our case, if we're emitting state, if a new consumer, a new component comes along, as soon as they subscribe, they're going to immediately get a state. We're going to build responsive applications. In my constructor, I'm going to go ahead and instantiate that behavior subject. And then in my dispatch method, when I have my new state out of my reducer, I'm going to use the subjects.next method to emit that state. Now, I don't want my consumers to be able to emit. So instead of exposing the subject directly, I'm going to expose an observable. And observables are like subjects, except they can't emit new values, they can only listen. So I'm going to convert my subject to an observable by using the subjects as observable method. Last step. All I want to do is initialize the state. So I'm just going to dispatch a dummy action. I'm just going to dispatch an init. This is what they do in NGRX. They just dispatch a init right off the bat, and that's going to run the reducer one time and create some initial state. So for basic applications, this 11 lines are all you need. A lot of times, I'm such a big fan of Redux, I'll just copy and paste this in for a basic application before I move on to NGRX or my own larger Redux library. So let's look at an example app and see this in motion. All right, so what I'm building here is a Donkey Kong shop. It's for Donkey Kong. It's pretty basic. You just click on each item in the store, and it'll just add up the total there, including some tax. Now, just like any great 2019 application, it's going to have a dark mode and a light mode, right? Beautiful. This could be another talk. So just to prove to you that I'm actually using the code that I wrote, I've just copy and pasted that store that we just wrote over here on the left. So that's our library code. Now, let's look at the consumer code that I wrote to interface with that store. So over here in my reducers file, I've included some state. I have the dark mode state. I have a cart array. The cart array, I'm just going to, every time I tap on an item, I'm just going to append that price to an array of numbers. So the array of all the prices that I've clicked on. And then a tax rate. I'm going to expose one reducer function. I reduce that add item action, which gets dispatched every time that I click on one of these items. It just adds that price to the back of the cart array. And then a toggle dark mode action, which happens when I click the sun. and it just inverts that dark mode state. Down here, I'm going to have a couple selectors that I've written. Now, selector functions are just functions that take in state and return some sort of result. This is nice for grabbing pieces out of state and computing derived data. So these first three just grab just different slices, different properties out of my state. And then this, the getTotalCost selector, actually does some computation and computes some derived data. Again, as a selector function, it takes in state, and it uses this getTotalCost helper function I've defined down here to add up all these numbers in the array and apply the tax rate. It uses the other two selectors that take in state in order to set up this function. So, pretty basic. Now, one thing you'll notice is as I click around, I've actually done some logging down here every time the total cost is computed. So we're computing that total cost, adding in the tax rate, all that good stuff. However, you'll notice when I click dark mode and light mode, it's still computing that selector over and over again. Over and over, just computing the exact same result. So that's the first thing we're going to look at is memoized selectors. Now, most libraries and NGRX or Redux expose a function that allows you to memoize these selectors. So I'm going to comment that out, and I'm going to define the same selector the same getTotalCost selector, this time using a createSelector function. NGRX provides this for us. We are going to look at implementing it. But first, let's just note that when I save, and now I toggle between dark mode and light mode, I'm no longer recomputing this unrelated state in order to get my total cost. There's our demo. All right, so let's look at createSelector. So kind of two pieces of functionality here we want to implement. The first is this ability to combine and transform other selectors. So we're taking in and we're combining this getCardSelector and getTaxRate, and then we're just applying one transformation function that takes these slices of state or this data and does my helper function to compute the total cost. The second thing we're going to do is we're going to provide it as a memoized function, meaning memoize is a generic software tool for optimization, but specifically here, when the input doesn't change, we don't want to rerun this getTotalCost transformation. So we're going to give this for free to our consumers. All right, so this is the function we're going to implement, createSelector. It's going to take in an array of selector functions and a single transformation function, and it's going to return us one selector function. It's going to create a selector. This is called a higher order function in JavaScript, createSelector. A higher order function, as a reminder, either takes in a function as input or returns a function as its return value. One kind of nice feature is that we can store some state across runs of this inner function. The inner function has access to all the properties and input of the higher order function. So looking at createSelector, it's a higher order function. A higher order function, it's taking in functions as input, a selector array, a transformation function, and it's outputting a single selector function as output. Now, a selector function itself takes in state and returns a result. So how we're going to do this is, for each selector array, for each element in the array, we are going to run it with the inputted state, and then we are going to pass the result of that selector function into the transformation function, and then we'll just run the transformation function, which will give us our result. Ready for some code? Here's our createSelector function. First thing we're going to do is we're going to declare a function, our selector function, and we're just going to return it. For each of the elements in my selector function array, I want to run that selector function. So I'm going to map the selector function array to an array of selector function results, running each selector function. And then all I need to do is return the transformation function result, passing in the selector function results as input. So I'm just using the spread operator here to put this array in as parameters to my transformation function. Pretty simple. Quickly, we're going to talk about memoize. So, for anyone that's not aware, when we have an expensive calculation and we call it directly, it calculates on every call. However, if we were to implement this higher order memoize function and we wrapped our expensive calculation, this returned memoize expensive calculation function would only calculate if the input differs from the last call. And so that's what we want with our selectors is if the last input is the same, the state we're dependent on is the same, let's not recalculate our derived data. So I've included slides and diagrams on how this works. I think it's kind of out of the scope for this talk. I've left in the slides. I'll post my slides. Feel free to look back at the source code. But we are now armed with this memoize higher order function. So coming back to create selector, first thing we're going to do, we'll memoize that transformation function. It'll output this memoized version of the same function. Instead of using the transformation function directly, we'll use the memoized version of the transformation function. And then last, we'll just memoize that selector function we're returning. A concept that's really essential to creating performant applications couldn't be any simpler behind the scenes. So we've looked at store, we've looked at memoized selectors. The last thing I want to look at is combined reducers. So this is actually one that I used to trip up on all the time. Like in NGRX, I wrote all of these reducers, and I can never really understand like how I get that into the for root in the store module, for those of you that are familiar with NGRX. But in general, this concept of how do I break up reducers and pass it in as one reducer function. This is what's going on in my demo app right now. I have kind of unrelated actions all in the same switch statement, and I'm doing unrelated pieces of state, manipulating them. But what I really want to do in my application is just break these up into different reducers. They're easier to test, less concerns, a lot of good stuff. So combined reducers is going to be a helper function. This helper function is going to take in these substate reducers. Each of their jobs is just going to be to reduce one section of the state. It'll be very simple. And then combined reducers will take all of these reducers and make a single reducer out of it. And then as you saw when we created our store, we're expecting a single reducer function as our constructor. So we're passing in just the single reducer. And again, in NGRX, store module for root, how do I do this? You just use combined reducers and you pass it in using for root. Function we're going to implement is combine reducers. We're taking in a mapping. It's going to be a key to a reducer. The key is going to be the state section that we want to reduce, and the reducer function will be the associated reducer. We'll pass in some initial state, and we'll return a single reducer function. If I was implementing this in my demo app, this is what it would look like. For each key within my state, dark mode cart tax rate, I'm just providing it one reducer. This is a good way to change your keys. If you want to switch easily what your keys are called, all you need to do is just manipulate the key here in your mapping. It uses it to create the state directly. So, another higher order function, combine reducers. This time we're taking in a mapping from keys to reducers. This is what it would look like in my demo application. And we're returning one single reducer function. Reducer functions take in a state and an action and return a new state. How we're going to do this is that for each key in my mapping, we're going to iterate through them. For each key, we're just going to grab the substate associated with that key, and we'll pass it into the reducer function associated with that key. We'll run the reducer function, we'll get some outputted state, we'll set it for that key, and we'll keep going until eventually, for every key, we've now accumulated each key of state. Last implementation. You guys ready? Here's my definition, reducer map. It's a dictionary. Our key is going to be a string. Our value is going to be a reducer function. Again, in the context of the demo application, this is what our reducer map looks like. And we have combined reducers. Combined reducers is going to define a reducer function and return that same reducer function. We're just going to return a new state at the end. How do we get here? The first thing I'm going to do is I'm going to convert this mapping into an array of keys. This is going to allow me to iterate through all of the keys in my mapping. But how do I turn that reducer map keys, that array, into just a single state? And here we'll use the JavaScript arrays reduce function. Reduce allows us to take an array of values and output a single value. So, we're going to pass in a function that tells JavaScript or TypeScript how we want to reduce. We are going to accumulate state as we go. We're going to continue to accumulate state. So the accumulated state will continue, and the key will be different on every iteration of this function. As we saw in the diagram, we're going to pull out the reducer function associated with the key out of the mapping. We're going to grab the previous substate, again using that key, and then we're going to run that substate reducer, passing in the previous substate and the action, and setting this new accumulated state at the key. Then let's just return the accumulated state, and the iteration continues until we have our brand new state. So let's look at all of this, and I'll prove to you that it actually works. We already saw we were using create selector here. Just as we implemented, just as I showed on the slides, it's just a few lines of code. Now for our reducer, we want to break this up into smaller reducers. So I'm just going to comment out this Donkey Kong app reducer, and we're going to recreate it using combined reducers. So I'm first going to write all of my reducers just divided up by a single concern, each dealing with a single action, a single slice of my state. And then we'll use combined reducers to just bring them all together. And we'll pass in the initial state just as we did in our original reducer function. Save and run. Save and run. And now we continue to click, and the reducer seems to still work, just as we saw before. Once again, because we're memoizing the selectors, we're not rerunning the calculation every time. Beautiful. I'll have my slides up. I'll be tweeting these out as well. I'm probably gonna, I had a lot of animations in there. I'm gonna try to clean up these slides just so they don't look so weird. Right now I just have the raw version updated, and you're just gonna see a lot of things overlapping each other. Oops. I'll work on that on the flight home. But I do want to thank you for coming to my talk. I hope you feel more independent from the documentation by understanding these key components. And I feel like you're a better Redux developer, and hopefully a better Mario. Thank you.